What's up, everybody? This is Mr. Richardson coming at you live through the power of the internet. What we're going to be doing in today's video is looking at how we can create confidence intervals for means or averages. If you're just getting here, make sure you checked out my previous video. In that video, we created confidence intervals using the margin of error for proportions. That information is going to be necessary to complete today's video, and I'm going to be referencing a lot of things from that video, so it's imperative that you watch it. I'll drop a link to that video in the description down below, but for now, let's jump right into it. In our last video, we talked about the margin of error, and I gave you an example where I absolutely loved the Biebs, and I was trying to figure out how many people in all of New York City love the Biebs. Well, if you recall, what I did was I went to a random subway station and I asked people as they left the subway station if they loved the Biebs. Now, what happened in that example was I asked 100 people and I found out that 25% of the people surveyed loved the Biebs. But the problem is I only asked 100 people, so I could never know how many people in New York City love the Biebs. In that example, the 25% was off, and what the margin of error does is it tells us how far we're off by. Maybe I could be off by as much as 10%, and that's what the margin of error would tell me. It would tell me that the 25% I got was maybe off by 10% or so, maybe less, but definitely no more. When we did margin of error in the last video, we did it for proportions. Proportion was that percent of the population. Remember, I talked about how many people of the 100 I had asked. In this video, we're going to do it for means or for averages, and there's a different formula. The idea for margin of error is still the same, but instead of doing it for the number of people that maybe favor a president or favor liking Justin Bieber, we're going to do it for things that have averages, like what is the margin of error for the average height of everyone in the United States, or what is the average number of likes a post receives on Instagram. The type of data we have is different. In our last video, we talked about a 95% confidence interval. What that was is if we had conducted that Justin Bieber experiment again, we were 95% confident that a value would fall within a certain range, and we used the margin of error to find that range. So we had to find a confidence interval as the interval that gives us a set of likely values that we are very certain that a certain specific value will fall within. Last time we used this formula, which was for proportions. Of course, today we're talking about averages. The formula is still very similar. We're still adding and subtracting the margin of error, but we're going to use the average, or X bar, rather than that sample proportion. You might be wondering why we use a 95% confidence interval. Well, there are different confidence intervals, but it changes the interval of that set of likely values. For instance, imagine a 95% confidence interval ranges between these two numbers. If I decide that I want to be 99% confident, what happens is that interval gets larger because I'm more certain. Similarly, if I had dropped from a 95% confidence interval to 90%, I'm not as certain, but the interval gets a little bit tighter. As statisticians, we decide to use 95%. It seems to be a nice balance between being pretty accurate and not having an interval that's too large. Let's jump into an example to bring this all together. In this question, a study of a local high school tried to determine the average number of likes that each student receives per post on Instagram. The study surveyed a random sample of 124 students in the high school and found a mean of 196 likes per post on Instagram with a standard deviation of 50 likes. Part A, find the margin of error for the sample, rounding your answer to the nearest whole number. Part B, determine a 95% confidence interval for the average, rounding all values to the nearest whole number. And Part C, is 202 a reasonable mean number of likes a student would receive on an Instagram post? Explain. In Part A, we want to find the margin of error, and for the margin of error, we have this formula here. What we need to know is the standard deviation and the number of participants in our study. Here we found that the standard deviation was 50 likes, with the number of people in our study being 124 students. Even though we don't need the mean or the average, let's write it down here as well. The average was 196. To find the margin of error, simply plug in and simplify. We can plug in the standard deviation of 50 and the number of students surveyed at 124. Calculating this, I would get a decimal. We're not looking for a percent here like in the last video. Remember that this is the margin of error for the number of likes, and rounding this to the nearest whole number, we can say that we're off by about 9 likes in each direction, meaning that if we did this again, we probably wouldn't get 196 as the average number of likes. That number might be too small by 9 likes or too large by 9 likes. That's exactly what we're going to do in part B, is we're going to find that interval that we're 95% confident that the mean falls within. So in part B, let's create that confidence interval where we take the average and add and subtract our margin of error. Plugging in our average of 196 and our margin of error of 9, all we have to do is add and subtract. Subtracting 9 from 196, I'd get 187, and adding 9, I'd get 205. What that means is that if we did this again, we'd be 95% certain that the average number of likes a student receives is somewhere between 187 and 205 likes. Part C, let's check for reasonable values. Is 202 a reasonable average number of likes that a student would receive on an Instagram post? The answer is yes. 202 is a reasonable value because it falls within our confidence interval of 187 to 205. Meaning if we did this again, we're 95% confident that the number of likes could be 202. Let's see if you can try one of these questions on your own. This question reads as follows. A study of a local high school tried to determine the mean amount of money that each student had saved. The study surveyed a random sample of 37 students in the high school and found a mean savings of $375 with a standard deviation of 100. At the 95% confidence level, find the margin of error for the mean, rounding to the nearest whole number. When we want to find the margin of error for the mean, we only need 2 pieces of information. We need to know the standard deviation and the number of people in our study. Here we said that the standard deviation was 100, and we surveyed 37 students. Plugging this into the formula will give us a decimal of 32.87 with a few other digits, and rounding to the nearest whole number, we're looking to round this to. The 8 says to round up, so we get 33. Choice A. What this means is that if we conducted this study again, that average number of 375 could be off by as much as $33. Maybe the average amount that students saved is too high by $33 or too little by $33. Problem number 2 reads, a study was commissioned to find the mean time students at a certain high school spend watching Netflix each week. The study examined a random sample of 25 high school students and found the average time spent watching Netflix to be 7.2 hours a week with a standard deviation of 2.2 hours. Create a 95% confidence interval, rounding all values to the nearest tenth, for the number of hours a student spends watching Netflix each week. In order to find a confidence interval, we first have to find the margin of error. Our formula for margin of error is as follows. Let's write down all of the key information. We need to know the standard deviation for this study, which happens to be 2.2 hours. We should also know how many students were in that sample. In this case, we have 25. And although we don't need it for the margin of error formula, we'll eventually need to know the average number of hours a student spent on Netflix, which in this case is 7.2 per week. Plug into the formula, calculate, and round to the nearest tenth. We get 0.9 for our margin of error. Now to create the confidence interval, take the mean and add and subtract that margin of error. Well, we saw that the mean was 7.2 hours with a margin of error of 0.9 hours. Let's plug in those values. 7.2 minus 0.9 is 6.3, and 7.2 plus 0.9 is 8.1. Let's try another example. Problem 3 reads that a survey was given to a random sample of people in the United States to ask how much money they typically spend on dinner when eating at a restaurant. The study examined a random sample of 100 people and found the average amount of money they would spend on dinner at a restaurant was $62 with a standard deviation of $8. Which of the following is a reasonable value for the actual average amount people in the United States spend on dinner when eating at a restaurant? Here we're checking for reasonable values, and in order to check for reasonable values, we need to know a confidence interval. Of course, to find a confidence interval, we have to start by finding the margin of error, so let's bring up our formula. Here a standard deviation was given at $8. The average amount someone spends was $62, and in this sample we surveyed 100 people. Plugging those values in, we can find the margin of error, which in this case was $1.60. Now we want to find a confidence interval. For averages, it's going to be the mean plus or minus the margin of error. Let's plug in. Our mean was $62 with a margin of error of $1.60. Adding and subtracting this, we get a confidence interval that goes from $60.40 all the way up to $63.60. What this means is that if we conducted this survey again, we'd be 95% certain that the average amount someone spends on dinner is between $60.40 and $63.60. So which of the following is a reasonable value for the actual average amount people would spend? Well, 60 is too little. It doesn't fall within our confidence interval. 61 is absolutely reasonable. That falls within our confidence interval. And we can see that 64 and 65 are just too large to fall within our confidence interval. So here $61 is the reasonable value. Let's try one final question. Question number 4 reads, a study by the Department of Education of New York City was trying to determine the mean SAT scores of the graduating high school seniors. The study examined the scores of a random sample of 50 graduating seniors and found the mean score to be 480 with a standard deviation of 86. Determine a 95% confidence interval for the mean, rounding all values to the nearest tenth. In order to determine a 95% confidence interval for the mean, we're first going to need to find the margin of error. The margin of error formula for averages or means is as follows. We need to know the standard deviation and the number of people in our sample. The standard deviation here was 86 after surveying 50 graduating seniors. We're also going to need to know the average score for later on in the confidence interval, so let's write that down as well. The average score here was 480. Plugging into the formula for the standard deviation and the number of people in our sample, we'd plug in 86 and 50, which would give us this decimal here. Rounding all values to the nearest tenth, I want to round this 3, and the 2 says don't round the 3 up, keep it the same, which gives us a margin of error of 24.3. To find the confidence interval, simply take the average and add and subtract the margin of error. Let's plug in. 480 minus 24.3 is 455.7, and 480 plus 24.3 is 504.3. Well, that's it for this video, and that's it for me. I hope in this video you learned a little bit more about confidence intervals and margin of error. Further, I hope you learned specifically how to create confidence intervals when the data presented is not a proportion, but is a mean or an average. Until next time.